we'll get started. Thanks everyone for joining us. It's great today to get to welcome Galo, Canizares, and Zach Cohen back to Knowlton today. Many of you may not remember, but in 2018, the Knowlton School launched the Yessios Visiting Fellowship. And this was a 2-year fellowship designed to bring people to the school doing interesting research in computation and digital fabrication in order to host workshops, develop projects, research projects, and to teach courses on the areas of their research. So in 2018, Galo, Canizares, and Ago were the inaugural Yessios Visiting Fellows. Galo was joined in 2019 by Zach Cohen. And during that time, the Yessios Fellows organized a year of workshops with important figures in architectural computation, developed 2 research projects resulting in 2 exhibitions in the Vanguard Gallery, and in January 2020, organized this symposium, Homing the Machine, which ended up being the source material from which this book was derived. So it's really great to get to welcome them back to the Knowlton School, not just to celebrate this accomplishment, but also to recognize the lasting impact their time here has had on the school and its engagement with digital fabrication and computation. So Galo Canizares is a designer, writer, and assistant professor at the University of Kentucky College of Design. Galo's work employs storytelling, fiction, and software design in order to explore what he calls softwareization, which, this is my definition of this term, Galo, so correct me if I'm wrong, but which is a neologism used to describe the ways in which the ubiquity of software today underwrites not only how we make architecture, but how we think architecturally. That's fair? Okay, good. Before he held the Yessios Visiting Professorship, Galo was the 2016 Lefebvre Fellow here at the Knowlton School. Galo holds a Master of Architecture degree from MIT and a Bachelor of Environmental Design from the University of Colorado Boulder. He's the author of Digital Fabrications, Designer Stories for a Software-Based Planet, which was also produced during his tenure here as the Yessios Professor, and is currently working on a history of Rhino and McNeil Corporation. Along with his work as a scholar, Galo also runs, along with Stephanie Sandelgado, the collaborative architectural practice Office Ka. Zach Cohen is an architect, researcher, and educator. His research into digital fabrication examines the ways in which the tools and processes of digital fabrication structure the labor of architectural design. In particular, his work looks very closely at the relationship between digital tools and the temporalities that they produce. For those of you who have noticed the kind of globby columns at the bottom of the ramps there, those are the product of Zach's research here, where he developed something called piling, which was a speculative method of 3D printing concrete columns without forms. It was a kind of intricate study of time, material behavior, and machine precision. Since leaving Knowlton, Zach has become a visiting assistant professor at the Cooper Union, where he teaches courses on robotic fabrication, and he's also the principal of Common Craft, a Brooklyn-based architectural practice currently engaged in multiple projects across New York. So please join me in welcoming Zach and Galo. How do you do presenter? Can you just click mirror? Screen mirror? So choose to mirror extended. Do we do extended? Let's do single start. Yeah, extended. It's right here. Okay. And I guess this just goes over here. Where's the notes?
It was there.
Or was it?
I think it's extended.
It's extended on that side?
Yeah.
Okay. And then the notes are... Sorry.
Sweet. Got it. Thanks, Curtis, for the intro, and thanks all for the invitation. It's nice to be back here. I'm Zach Cohen. That's Galo, if that wasn't clear. And I guess before we get into it, so we've given this talk a few times now, or a couple times at different places, and I feel like sometimes we jump into it without giving a little bit of context on what digital fabrication is, which is kind of the point of the book in a way, is to explore the definition and potentially expand it. I mean, and I'm not going to do that right now. I'm just going to say that that we're going to try to answer that conversation through the book and through this conversation, and that this book is generally intended for people that have no background in digital fabrication. It's meant to be a kind of intro to this emergent world that we participate in and contribute to. All right, so what we're going to do today is a few things. We'll intro the structure of the book, talk about its concepts, its motivations, and then we'll show some examples of contributions in the book. And then if we have time, which it seems like we probably will, we can have a conversation with you if you're interested. But to begin with, we wanted to talk about the book's organizing metaphor, which is also its title, which is homing the machine. So if you've used a digital fabrication machine, in all likelihood you have homed that digital fabrication machine. And in case you don't know what that is, what that means, to home a digital fabrication machine is to specify its origin point, the point at which it begins making. And homing is necessarily the first step in every digital fabrication process in order to sort of orient the machine in space, right? Without this homing routine, without this homing process, digital fabrication machines would otherwise kind of be lost in a sort of vacuum of space, we could say. And so when we create digital fabrication programs, we generally either specify the origin point specifically based on the thing that we're making, or we just use the default origin point that's specified to the machine, in which case it's just a button click or a box checked. But if we decide to specify our own origin point, we often do so in consideration of the kinds of materials we're using, or the scale of the thing we're building, or the fragility of the thing, of the structure of the thing. So each time we digitally fabricate something different, we may decide to change the digital fabrication's digital fabrication machine's origin. In this way, origin points demonstrate how what we decide to digitally fabricate is inextricably intertwined with how we decide to digitally fabricate, suggesting that physical origins are always in some ways related or intertwined with conceptual origins. And so, since digital fabrication's introduction to the field of architecture, architects have conceptualized many different things for digital fabrication machines to make, from laser-cut metal pavilions on the left to 3D printed kind of pseudo-Baroque grottos on the right. And this applied research has resulted in a variety of different approaches and ideologies, as well as many different origin points. And yet, the discourse of digital fabrication and architecture has generally remained centered on the sort of technically oriented rhetoric inherent to digital fabrication's industrial origins, and on tools rather than values. So here, if we look at some of the recent themes from the biggest digital fabrication conferences in architecture in the world, we can infer the ways in which digital fabrication is discussed. So starting on the left, this is the ICADI conference from a few years ago, entitled "Architecture in the Age of the Fourth Industrial Revolution." So immediately we can see that digital fabrication most often is sort of seen as a continuation of industrial principles of the discourse of industrialization. Sigrati from 2023, entitled "Accelerated Landscapes." So again, kind of dovetailing on this idea of industrialization, there's there's a kind of fixation on speed, doing things as fast as possible, accelerating processes, existing processes, in this case accelerating natural processes even. Cadrea 2024, I guess it is, still accelerating, still not fast enough. Now it's accelerated design. And then most recently, last year, the Ralbar conference was beyond optimization, which is kind of like an implicit acknowledgement that we are fixated on things like speed and optimization and trying to move beyond them. But I would argue if you look at the proceedings of that conference, we're still very much stuck in that world. So the friction between the sort of persistently technical nature of digital fabrication or the technical nature of this type of research and the conceptual nature of architectural design has made it difficult to locate digital fabrication's origin or home within the greater discipline of architecture. But for us, given the amount of subjectivity involved in digital fabrication, from homing to the machine to deciding how we realize digitally fabricated assemblies, we felt it was time to look at the decision-making processes behind the more often discussed technical details. And so in this book, we fundamentally ask two questions. What are the conceptual origins from which our physical origins emerge? And how these conceptual origins inform the kinds of things architects and designers have decided to digitally fabricate?
And so our use of origin operates in a few different ways. I think for us, it's primarily the point at which something begins or from which it derives, right? So etymologically, it's just like, where does something start? Like, where did digital fabrication begin? And we're looking at that both historically and conceptually, right? So this idea that the sub-discipline of digital fabrication within architecture had to have started somewhere. But then we're also thinking about it as ancestry or parentage, right? Thinking about a genealogy of digital fabrication, not in a singular way, but maybe in a kind of branching way. Thinking about how the lineages within digital fabrication practices fracture, fragment, and interweave throughout at least the field's relatively recent history. And so, in our introduction to the book, we try to at least establish some origins. We make it very clear that we're not writing the history of digital fabrication, but we're kind of compiling potential histories of digital fabrication. So this is probably one that is pretty familiar to a lot of architects, that the narrative that digital fabrication perhaps originated with a kind of desire to build complex form. I think this is one of the most popular narratives, at least in the history of architectural movements or architectural style, right? There's terms that are affiliated with this type of approach, something like parametricism or blobitecture, right? And something that comes out of the desire to produce complex geometry. And so the digital fabrication, in this sense, originated from the desire to actually be able to make something that looked like this, right? It was necessary to make, to have tools and processes and software and hardware, et cetera, that could facilitate the production of something like this. Other origins maybe are a little bit more culturally based, right? So this idea that in the 2000s, late 90s, 2000s, there were smaller practices that were a little bit more experimental and that weren't necessarily interested in building curvilinear museums, let's say, right off the bat, but we're more interested in looking at what the tools can afford, right? And so this is Bill Massey's winning entry to the 2002 PS1 Young Architects competition. And this was a sort of celebration of CNC milling, where the forms were derived through software that facilitated curvilinear surfaces, but then it was the making of the realization of the surface, the realization of the parts, and the detailing of this that maybe conceptually was a watershed moment, right, for digital fabrication. And still, maybe it could also be argued that the architectural variety of digital fabrication, which is distinct from, let's say, industrial digital fabrication or product-based digital fabrication or scientific digital fabrication, really started maybe when we started stacking robots, right? So when Gramazio Kohler Research published their paper and projects related to brick stacking in 2006, maybe the architecturalness of digital fabrication actually began when we started using bricks, or thinking about the tradition of architectural tectonics in relation to digital fabrication. And so that is to say that maybe the origin didn't really come from the smooth curvilinearity, but really more from detailing and tectonic approaches. And so parallel to those three, let's say, myths about the origins of digital fabrication, we could also suggest that from a critical history type of approach, texts like Daniel Cardoso Lache's Builders of the Vision prioritize different kinds of beginnings or histories of digital fabrication. His is fundamentally a history of hardware, and it looks really at the origins of CNC machining and how the hardware that was developed at MIT in the servo mechanisms lab that basically established the protocols that would eventually become the methods and the constraints within which CNC milling and fabrication in general happens. And so we can kind of establish a pretty clear genealogy of hardware in a way from these beginnings. Elsewhere, we could look at software as well as another kind of origin point. And so here, Greg Lynn and his Archaeology of the Digital Project really looks again at the software that was used to facilitate curvilinear buildings, particularly in really specific sites like Frank Gehry's firm and Peter Eisenman's office as well, where they were using computation to solve particular form making problems. And so it could be argued, at least Greg Lynn argues, that this is a key origin story because this is really where we started to make something that was architecturally digital, right? And so software maybe is what changed the game here. At the same time, it could be also said that each instrument or each tool maybe has its own history that is worth acknowledging, right? And so in Design Techniques, Archaeologies of Architectural Practice, Zainab Celik-Alexander and John May trace the individual lineages of particular techniques and tools and instruments that in a way have their own nuances and their own ancestry as well, that eventually trickled into architecture through different means, right? And so the question here becomes, is it maybe worthwhile discussing a history of the laser cutter or a history of the 3D printer in addition to the history of the CNC mill, for example? And so that's all to say that what we're really trying to engage through these various interleaved narratives and genealogies is what is critical digital fabrication, or what can be a critical digital fabrication. And to a certain extent, this is really what we were asking our contributors to the book, and actually what we asked the symposium participants way back in 2020 as well. And so just to show you how the book is organized, we established three primary lenses through which to look at the origins and histories of digital fabrication. The first is the technological, the second is the material, and the third is the social. And these lenses allow us to look at these origins and lineages from different positions and really explore this idea of trajectories, going back to the homing and coordinate metaphor that we're using, looking at how different trajectories across history and across time converge or even diverge within the field of digital fabrication. The technological is probably the most familiar to everybody. The technological really discusses practices that put technology and the tool first. In that section, we've got figures like Michael Zybos, Maria Jablonina, Stefano Parascio, Marshall Prado. Right? These are what you would call architectural technologists, first and foremost. Right? They're involved in developing new technologies, customizing, building custom tools, custom software, etc. In the materials section, we have people like Leslie Block and Sasha Zikovic, Zachary Malika, Ehsan Barlu, Skylar Tibbetts, people that are engaging digital fabrication through matter and material exploration, right? This spans ideas such as, using existing materials differently, exploring under-examined aspects of existing materials, or even developing new materials, right? Developing maybe autonomous materials or biologically intelligent materials, per se. And then in the social section, this is really where we think we are contributing probably the most in terms of the discipline, because we feel like the social aspect of digital fabrication is also kind of under-discussed. And so in this section, we have James Coleman, Nathan Barnes, Paolo Cascone, Madalena Ladaga, Pablo C. Herrera, Shelby Doyle, Vernell Noel. And these are individuals that, even though they might not necessarily themselves say that they prioritize social issues, we, as the editors, sort of really found very strong social agendas and social threads in their work. And so we started to ask them questions that highlight that aspect of digital fabrication. Things like, what are the politics of the Fab Lab? Or how is digital fabrication knowledge transmitted across continents, for example? And the last thing that I'll mention is that interweaving these sections are more theoretical reflections on the state of digital fabrication today from mostly historians and theorists. So we have Theodora Verduli in the technological section talking about what does it mean to home a machine, what is the sort of identity of a machine in the world of architecture, more sort of theoretically. We have Francesca Hughes, who talks about the origins, the sort of origin of thinking about origins historically, like all the way through the Renaissance, and thinking about like the relationship of the body as a kind of primordial origin, and looking at how we sort of communicate ideas about the body and origins of the body and body-like metaphors, and how those extend to machines eventually. And we also have Mark Rosenbeck that has this really quirky reflection about a robot named Heidegger. I'll just let you read it and reflect on that. But now we're going to get into the book and just really quickly kind of take a stroll through some of the chapters.
I feel like that cart is heckling us. We're going to share some contributions of what we call origin stories, kind of play on the sort of superhero origin story, if you will. And I guess before we get into it, something that just occurred to me on seeing the Galo talk is that I want to make clear is that origin stories, though they're called origin stories in this book, or this idea that architectural research has an origin is not specific to digital fabrication, if that's not clear. I think all architects have origins of different kinds, maybe, and I think the work of genealogizing or tracing your origin is kind of fundamental to architectural research in general. And so, at least that's my view. So I think we're trying to show that the same exercise of genealogy or genealogizing and finding one's origin can be applied to digital fabrication, and by kind of running digital fabrication through the sort of origin tests or origin exercise, try to locate it and situate it within broader architectural discourse or discourse on architectural research. Okay, so just gonna hear that cart everywhere. The first contribution we'll share is from Mike Zivos, who is founder of a practice called SoftLab, a design and fabrication practice based out of New York City. Mike's also a professor or a lecturer rather at Yale University, where he teaches courses on computational design and also design studios. So the beginnings of Mike's practice, SoftLab, can actually be traced to an independent study that he conducted in an architecture school. And in that study, he aimed to investigate what was a kind of simple and perhaps naive question, and it was, how can architects use computation to automate a fabrication workflow to build a quote-unquote complex surface? And because this study took place in the mid to late 90s, a time in which relatively new digital modeling technologies enabled new formal explorations that sort of either redefined or introduced this idea of complexity in architecture. Complex here means doubly curved surfaces that cannot easily be rationalized into repetitive component parts. And so in this early work and in nearly all of SoftLab's subsequent work, the design team sought to automate both the form making and the fabrication of these complex forms. So the idea was that new digital fabrication technologies could and perhaps should create more seamless transitions between digital forms and their material manifestations. But as anybody who's used a digital fabrication machine can attest to, things aren't always as seamless as we want them to be, and Mike found that out quite quickly. So his team ended up actually relying very heavily on physical prototyping to determine, what material connections were actually feasible, and what material connections made sense in the logics of these sort of complex surfaces, and sort of created a dialogue between the physical prototyping and the computational design and digital modeling. And so in addition to not being able to accurately automate tectonics in the digital world, Mike and his collaborators could accurately simulate material properties, a thing that's actually still quite difficult to do, even though software is much better these days. And they couldn't, at that time, accurately simulate gravity. So when they began building larger scale prototypes, they quickly discovered that plywood panels and metal plates weren't sort of viable material analogs to NURB surfaces. That something was sort of lost in translation between the two. And so eventually they did come up with a sort of flexible joinery system and a friendlier material, which was laser cut chipboard. But when they finally built an installation to demonstrate their new automated design and fabrication workflows, they found the result to be clunky, both in sort of production and experience. You can see the many sort of gusset plates or splices that are used to make this thing actually work. And so it was, in other words, not really close enough to the sort of complex doubly curved surface of their digital imaginations. And so they set out to invent new ways to bring the physical closer to the digital, or vice versa. So the next iteration picked up on another fascination of early digital architecture, which was gradients. And so in this new installation, SoftLab set out to materialize essentially a three-dimensional rainbow through a sort of gyroid or gyroid-like form. And partly because of the previous difficulties using thicker, heavier sheet materials, and partly because of the need to precisely map the gradient, this color gradient on each panel of the form, the team used off-the-shelf printer paper as their panel material. The paper first had its sort of unique portion of the gradient, the 3D gradient printed on it, and then it was laser cut to give it its final shape, which involved cutting out these sort of foldable tabs that enabled each paper to connect to its sort of adjacent neighboring panels through nothing but binder clips. And so the result was a sort of inhabitable material gradient that closely resembled the digital model upon which it was based. Obviously, or maybe not obviously, but on the left is the sort of Rhino screenshot, and on the right is the actual thing. And so for Mike and his collaborators, this set up a sort of desire to continue to push and also, I would say, point to the tension between digital and material worlds. And even perhaps the tension between the sort of digital and public worlds to some extent, one might say. And so this desire became the main driver of the studio's sort of evolution, pushing them to build digital turned material structures that were increasingly lighter and more complex, but also able to continue to sort of blur into or even recede into their physical surroundings. But through the evolution of the studio's work, they continued to return to physical modeling, and it became the sort of origin in which the origin that oriented their work, so that their digital designs never strayed too far from what was materially possible, as was the case in that sort of very first project. So it's sort of this constant dialogue between the digital and physical that grounds the work, that orients it, you could say. Okay, the second contribution we'll share, and also let me just say, I feel like these might be in terms of like each section, but like we're intentionally not saying who's in what section, because for us the sections are entangled and there's lots of overlaps, and actually, although I think we grew to like the sections, we didn't want sections, we didn't want to group people. I was kind of like against the whole idea of the project. It's that there was like a variety and a diversity that should be embraced rather than fixed categories. Anyway, but here's, I guess, another technology person if you want to go by the book, so to speak. So the second contribution we'll share is from Maria Jablonina, who's a professor at the University of Toronto. And similarly, her origin can be traced to her studies. She was a graduate student at the Institute for Computational Design and Construction at the University of Stuttgart in Germany. A school that was like one of the first to introduce a degree program solely focused on robotic fabrication. And from its inception, it immediately attracted droves of students from all over the world that were eager to learn these new technologies. But when the first cohort of students arrived, they immediately identified a big problem, which was that there's only one robotic arm for all of them to use. It's a problem that's actually now quite common in a lot of architecture schools. So robotic arms, for those that don't know, are kind of like the de facto tool for any architect wanting to do robotic fabrication. They're usually whether you know it or not, kind of what pops into your mind when you think of robotic fabrication. And so not wanting to fight for robot time with her peers, Maria decided to improvise. And ultimately decided to build her own small sort of army of robotic fabricators. So a decision which initially stemmed from really a sort of logistical problem and a need to be resourceful actually grew into a practice that even to this day is quite unique within the field of architecture-oriented digital fabrication, and that's a sort of a practice of designing through the design of personalized fabrication machines. So in a way, it's she was heavily influenced by the sort of DIY and maker movements that are still gaining momentum. But at the time, those were sort of novel approaches to digital fabrication, and not ones that actually, and still I would argue, don't really have a place in academia. They're sort of seen as sort of like the hobby kind of leisure version of robotic fabrication. After building these robots, Maria found out a lot about, or through building them, really, she found out a lot about what they could do and realized that they could do a number of things that were difficult or even impossible for large industrial robotic arms to do. For instance, they could agilely climb walls and nimbly weave together three-dimensional webs of delicate thread. And because she designed them, she could design them to be more readily responsive to her, their maker. So she often designed them to be operated much like video games, in which she was the one and only player. And actually, in this, which was her first major installation outside of the university, she's controlling the machine with an Xbox controller. And so what she found herself to be doing as well, from a kind of philosophical or even ontological standpoint, was sort of creating a horizontal or a more horizontal or balanced human-robot interaction, not one like an industry in which you tell the robot to do something, the robot does that thing. Hers is a practice in which she's much more collaborative with these little creatures that she designs, and they sort of speak to her and she speaks to them. And so she really treats her robots as sort of like pets, almost, I would say. But assuming you treat your pet well. And so over the years, Maria's grown it. The practice has grown into one that actually, in my opinion, more closely resembles performance art. She now designs worlds in which the sort of labor of her and her robots are put on display. And these performances result in these sort of somewhat uncanny artifacts that exhibit, I think, some of the digital blurriness of Soft Lab's work, in which it's ultimately difficult to say who or what made this thing, and that's kind of the point, is because it is very much a collaboration, both in the kind of in a physical sense, but also in a maybe even a kind of conceptual sense. The robots are responsive to her, so they do have, in a way, a mind of their own, and are able to improvise with her. But a sort of a key difference from Maria's work to Mike's work to actually much of the other work in the book that's presented is that these machines and these structures are sort of inextricably intertwined with her, and so it's this sort of personalness or personality, we could say, of Maria's work that I think makes it truly unique.
So the next chapter that we're going to talk about is Zach Malika's chapter called Working with Forests. And Zach, I believe he's at Toronto, but he used to be at the AA in their Hook Park location, which is actually in a forest in the UK. And so the chapter actually goes through his experience as being almost like a caretaker for this forest that's owned by a school of architecture, which is really a unique kind of situation. And so for Zach, his new technologies basically allow us in the discipline in general, as he says, to augment our understanding of materials, right? And so in the projects that he presents in the chapter, he really dives into technologies, not necessarily for design, but really for understanding, or for getting more information about materials, specifically forests and trees. He starts off really by looking at, looking at different origins. And this is actually an example from, I believe it's the 18th century or maybe 19th century. Apparently boat builders used to actually comb forests and look for particular structures that exist already in the forest and mill a tree specifically for its position and for its unique structural posture, essentially. Because some of these limbs, the way that some of these grow, actually are very strong but also very flexible. And so they started to, through empirical processes, figure out which trees would be good for certain parts of boats. And so Zach actually sort of sees himself as continuing this type of lineage, where he's really interested in working with a tree in the way that it already exists. So in a way, he's kind of countering the modernist narrative of standardizing parts, right? So he's not really interested in the standard, but really looking at what the existing condition can offer. And for that, he really needs a lot of digital technology, right? So not necessarily fabrication technology at the beginning, but really surveying technology, right? So he's using a lot of surveying tools, lasers, scanners, and really starting to understand how the material that he wants to work with already exists, and then moving to a kind of cataloging phase, right? So he's surveying the wood that is available to him, and he's cataloging it. And so again, he's using these relatively recent technologies related to like database organization, and even machine learning, machine vision, computer vision. These technologies that allow us to sort of filter through images and data sets very quickly. And he's amassing just these huge catalogs of different parts that come from existing trees. And this is a quote that he has in this chapter. It says, 3D scanning and related digital technology, digital tool sets present the means to engage the world's forests in the shape that they are now in. Which again, for him, is a kind of sustainable paradigm, right? This idea of doing the most with what you already have rather than producing a lot of waste. So there's also this, somewhat sustainable agenda that he's also working with. But I think that there's also a representational agenda, because he's not only developing these workflows to analyze and gather information related to the trees and wood materials, but he's also trying to figure out ways to represent them and to almost architecturalize them in different ways. So much like the boat builders that were, making these templates for working with existing trees, he's trying to figure out like how whether point clouds are the most useful format for this mode of representation, or maybe something a little bit more architectural, like serial sections, wireframes, mesh representations. And so there's a kind of mini project, or there's actually a few different projects within the larger project that he's engaging in. But ultimately, this is the one iteration of the culmination of this type of work. He works with engineers and tries to, maybe optimize is not the right word, but really tries to make efficient use of those the data sets of 3D scanned pieces that he's got, right? And so it takes a long time for it to get to the design phase. But once you're in the design phase, then it's really, design becomes almost like a collage or a kind of aggregative process, right? Where you're trying to fit in these pieces like a puzzle. And so the design doesn't come from the top down, it comes from the material outward. James Coleman and Nathan Barnes present a really interesting chapter in our book. They are not academics, they are primarily practitioners, and specifically fabricators and technologists. They were both, James used to be at Zaner, the metal fabricating company, and Nathan Barnes is now, I think he's the lead, the research lead at Zaner. And James actually went off and he made his own company now. And he's working with big clients like Google, for example. And their specialty is basically full-scale digital fabrication, right? So this idea that the goal maybe with digital fabrication projects is to produce a building, and that pavilions are maybe prototypes for bigger full-scale building size projects. Like they're really interested in realizing that, right, the architectural scale digital fabrication. And so this is really the case study that's presented in the book, which is the Google headquarters, which at the time actually was sort of an anonymous project because he couldn't really share too many details because it's Google, but now everybody knows what building this is, right? And specifically, Zaner was actually not in charge of too much of this. They were in charge of the complex geometry in the eyebrows. I think they called them eyebrows, which is actually each of these panels that form these eyebrows are actually pretty geometrically complex. And so Zahner prefabricated them, and in the chapter they go through the sort of the ways in which they thought about the production of these pieces. And what becomes kind of obvious or becomes evident in their story is that they're using a lot of the skills that they learned in digital fabrication labs at MIT and different schools that they attended, and they're putting those into practice. And what comes out of the story is a series of cheat codes for construction. He calls them construction cheat codes, which are essentially like best practices or lessons from digital fabrication. And so they're really suggesting that digital fabrication is a unique form of knowledge that gets you to see assemblies in a different way, or gets you to see the process of making in a different way. And some things that really stand out for them are things like making jigs, right? Jig making is a cheat code that when you want to fabricate something more than twice, it's worth making a jig that can repeat the same operation. And they're really using these cheat codes to quote, like, leverage technology to improve construction. So here are some of the hacks or some of the jigs that they were developing. Or this is actually some of the eyebrow pieces as they're. I don't know if this is a mock-up or it might actually be a full-scale production. But they also make these claims that are almost provocative in the sense that they're really trying to change construction, which is a notoriously conservative area in architecture, right? And they say that checklists and jigs are better than drawing sets, right? So this idea that if you're in the digital fabrication mindset, you don't really care what a drawing is. You really care about the jig and the checklist of all the parts that you want, right? And obviously models as well. And so they're sort of suggesting that construction could potentially move towards a fully sort of model based CA, construction administration and construction phase. But not only are they concerned with documentation and communicating information through models and data and jigs, prototypes, etc. They also are interested in reorganizing the process of construction in general, right? And so one of the things that they touch on is this idea of safety, right? The longer that you have construction workers in more precarious positions, the more risky the whole process becomes, right? And so this affects like insurance, and it affects like time on the job site and all of this kind of stuff. So they're sort of tangentially addressing the logistics and the more boring, let's say, aspects of construction, that are things that maybe we take for granted. But they're suggesting that if you are in the digital fabrication mindset, you can actually produce a safer job site, which I think is a really, maybe provocative claim to make. And so even though they're, make claims about like tolerances and alignments and surveying, verifying in the field that all the locations are precisely made with point clouds and all this kind of technology, ultimately what their goal is really just to shake up construction. And so the lessons that digital fabrication offers full-scale construction, according to James and Nathan, are really to look holistically at how construction can be rethought. And they're really accepting the nuances and the idiosyncrasies of being in the field, and they're using their experience as full-scale fabricators to tell these stories. And James also actually worked with Maria to develop surveying robots for projects. I don't think it was this project, but it's another project for a big client. And so they're also, I think what's really interesting is that you have a lot of a lot of dialogues that cross the author's practices in the book. And here are just some more images of the Google campus, and really, I think it's a really interesting reflection, and why we were excited to include it in the book is because it touches on things like accessibility of construction, right? Because these really complex, geometrically complex buildings that maybe were limited to the Garys and the Heatherwicks of the world could at a certain point become a little bit more accessible if the construction industry sort of changes, right? And we figure out that it's actually maybe easier and safer and maybe cheaper to build in the future. And this is just a kind of detail of that process as well. Another chapter that this is in the social section of the book is this really interesting contribution by Paolo Cascone and Maddalena Ladaga, who lead the co-design lab. And we decided to include them in the book because they're doing a lot of work in the global south. And something that we were thinking about as we were putting together the book is, how is digital fabrication knowledge disseminated across the globe? And obviously, if you look at these lineages and genealogies that we've got, they're very specific sites where digital fabrication knowledge and practice is kind of concentrated. Stuttgart is one, ETH, another, maybe MIT in the US, and these sites, obviously, because of economic reasons and a lot of other reasons, are located in the global north. We were curious about what does digital fabrication kind of look like elsewhere, right? And this is one of two other sections that address this theme head on. The other one is by Paulo Herrera, who talks a lot about how knowledge is typically exported from the global north into the global south, right? So a lot of digital fabrication practitioners go to school in Europe and in the US, and they take that knowledge into their home countries. Paolo Cascone and Maddalena Ladaga, they are sort of nomads. They work in Europe, but then they also have offices I can't remember exactly if they have a permanent office, but they've worked in different cities in different countries in Africa. They worked in Morocco, Ghana, Burkina Faso, and Senegal. And what their project is sort of called is the African Fabrics Project, which is a sort of broad initiative that tries to blend digital fabrication knowledge with local building and fabrication traditions, right? So they're not necessarily interested in coming in to another country and sort of, teaching the local community how to build in the Western tradition. They're actually interested in making tools more accessible and then combining the tool knowledge with local fabrication or construction knowledge in order to see what can emerge out of that. So the African Fabrics Project is really a pedagogical project for them. And more logistically, what the project kind of entails is the establishment of curricula and workshops and actual building sites that produce communal and participatory making practices in these different locations. A lot of their work is actually funded by, I believe, the World Bank and the UN. So they get a lot of grants from international organizations in order to facilitate these initiatives. And really what they're looking at is establishing platforms, right? They say we conceived of our architectural projects as creative open platforms, instead of urban infrastructure is able to provide spaces of production, both educational activities and community-oriented projects, right? So they don't really necessarily see the artifact, the digital fabricated artifact, as the end goal. They're looking at knowledge transmission, knowledge sharing, community building, building infrastructures and platforms through various material modes, right? And so here is a kind of map that they established to show really how they work and the different regions that they work, the different materials that they work through, the different systems. And these are more of the fabrication approaches, right? The sort of the geometric, more formal strategies that they're interested in producing. And then some of the programmatic agendas, right? So they built cultural centers, they built fab labs. I think the fab lab is probably the most interesting aspect, which is sort of modeled after the concept of the Fab Lab network, which was founded by the MIT Center for Bits and Atoms. And that is an initiative to create these kind of satellite fab labs all throughout the world that all can communicate and share knowledge together. Like they share like models, but also scripts and tutorials and writings in various ways. And so here's where we see how the kind of infrastructure network all kind of fits together. And so these are just some examples of the sort of infrastructures that they establish in these different sites. They prioritize a circular economy, which means that they are always looking at local materials, local wood, local construction knowledge, etc. And yes, they teach obviously the locals how to use the new machines that they include in their infrastructures. But then, obviously the community takes ownership of these sites as well, and so they kind of build their own fab labs and their own community centers, and then they customize them and to personalize them. And so something that's kind of interesting about the African Fabbers labs is that they tend to look familiar. In terms of the shared language of digital fabrication, like you see sort of maybe parametrically variable openings, maybe some triangulated components, etc. And so that really maybe is part of that imported knowledge that comes in from just traditional digital fabrication, or maybe even we can call them digital fabrication tropes. But it's also I think it's also important to understand that a lot of the materials are like rooted in the locality, and so they also have a pedagogical aspect, right? So as they're designing this is them in the process of designing I believe it's the Douala Cultural Hub. And that project itself is this sort of hybrid community center / makerspace / school. It includes a school of fine arts, some exhibition spaces, other kinds of labs, and a courtyard. And they involve the community in the design of this, right? So they're not coming in, let's say, from the top down and establishing themselves as these, singular designers, but they're really working with the community. And it's kind of interesting that the building itself was fabricated. I believe it was fabricated also with parts like from the lab itself.
Okay, so the last contribution we'll share is from Shelby Doyle, who is an associate professor at Iowa State University. And before we get into it, I think this contribution or this chapter is even more relevant now than it was when the book was published, given the unprecedented, really, intervention of the federal government in university curricula and administration. And you'll see why in a second. But I think there's a lot that can be learned from what Shelby did in her, or still is doing in her university, and a lot that, frankly, we'll all need to learn how to contend with in our own ways, in soon. So in her case study, Shelby advocates for what she calls technocultural origins instead of scientific origins. And she argues for this sort of technoculture as a means to create more diversity and inclusion within the field of architecture-oriented digital fabrication, a field that is often has a sort of high barrier or high bar to entry for either reasons of resources or or just because of the lack of representation throughout higher education in general. But so technoculture, for those unfamiliar, is a way of looking at the world through the intersection of technology and culture, as the name suggests. And Shelby's own technocultural origin, a practice that she calls computational feminism, derived from her personal background as a female architect with a tenure-track appointment in a STEM university that, like many STEM universities, including this one, is bent on quote-unquote innovation. And so her appointment was centered on the development of a lab that innovated work in digital fabrication and design build within the university's Department of Architecture. So she was tasked with building both the physical lab space and its culture, both from the ground up. And the resulting project became what is now the ISU Computation and Construction Lab, which is a 5,000 square foot, fully equipped makerspace housed within a former soundstage. And so in naming her research space, Shelby's use of the word lab is both intentional and intentionally ambivalent. So labs, as many of you might know, are sort of deeply entangled in ongoing attempts across higher education in the U.S. to sort of entrepreneurialize the humanities and scholarship in general. The conceit being that literature and history are not good enough of themselves if they don't generate income for the university. And so it was, when she presented this idea of a lab, it was immediately appealing to her sort of university overlords. And at the same time, for her, from a more historical and philosophical standpoint, the invention of labs is rooted in Enlightenment era search for sort of scientific knowledge. Feminist thinkers that she admires, such as Ursula Le Guin and Donna Haraway, for those thinkers, such scientific knowledge is conceived, constructed, and understood through social practices rather than bestowed upon us by some God-given truth, right? It's not an absolute knowledge, it's very much a relative knowledge based on context and culture and socialization. So Shelby's lab aims to hold the values of science and technology and the values of humanity in tension. As she says, to construct a pedagogical and research space under the guise of the quote-unquote lab at an institution of science and technology, the term lab is used both earnestly and as a decoy, smuggling Bauhausian studio traditions of clay, textiles, metal, stone, glass, and color, minus the exclusions of women from the architectural guild, into an institution that prioritizes hard sciences. So there's this idea of kind of like pulling a fast one, let's say, on the university by sort of appealing to their desires for innovation, but actually creating a lab that is much more focused on culture and craft and things that might not actually be appealing to them if it was presented under some other kind of name. So there are four continually evolving aims that inform the development of Shelby's lab and this idea of computational feminism. So the first is testing ideas at full scale through built projects. The second is materializing computational practices through digital fabrication. The third is questioning education's role in replicating existing technological equities or inequities. The fourth is pursuing technology and architecture as a space of gender equity rather than one of gender exclusion. So some projects from the CCL lab or the CCL include 3D printing ceramics, robotic painting, a laser cut installation for a student-led performance, a fabric cast concrete wall, and an interactive pavilion composed of illuminated 3D printed parts. And also as part of the 4-point mission, the CCL puts out a number of publications on topics such as intellectual attribution and craft. And so through this kind of dual pedagogical and research effort, she aims to encourage architects and designers to recognize feminism as a technocultural framework with practices, methods, and theories from which architecture, computational design, and digital fabrication can both sort of learn and orient themselves. And she's sort of quick to point out that while progress is slow, if you search feminism in HumanCAD, which is the digital fabrication database, if you search in 2017, there's one contribution. If you search now, there's at least 4, 3 of which are hers, I think. So some progress, but progress in academia is slower than we all would like. Okay, so we'd like to end with a reference point. So Galo mentioned we have these sort of essays interspersed, these sort of critical reflections or essays interspersed throughout the book that we call reference points. The idea behind these sort of interruptions is that they can provide readers with an opportunity to sort of reorient themselves through the book's variety, but also that they potentially could start reading the book from many of these given points, right? You can start in the middle, sort of pick your own origin, if you will. And so each reference point is a new lens or new way into the book. So in that vein, we want to sort of end or arguably begin once more with an excerpt from a reference point by the architectural historian and theorist Mark Yarzenbeck, which he entitled A Robot Named Heidegger. And for those unfamiliar, I feel obligated to caveat this by saying Martin Heidegger is a he's widely considered one of the most influential continental philosophers of the 20th century. He was also a Nazi, so we should all just remember that when we think about Heidegger. Anyway, in this piece, Yarzenbeck critiques the ways in which the Western sort of collective imagination of robots has largely been dominated by the idea of the robot as a kind of humanoid automaton. In other words, we often approach robots or a robot as a kind of body, specifically a kind of human body, rather than as a kind of mind. And so Mark argues that this fixation on physicality can be traced back to the Greek myth of Talos, which was a giant bronze robotic soldier that supposedly protected the shores of ancient Greece. And he argues that since that time, every robot in Western imagination has been some form of Talos. And he asks, what if we approached robots differently, not in terms of bodies, but in terms of minds? So he writes, and I apologize for the length, but I felt it was necessary to sort of communicate the spirit of the piece, and I hope you'll see why. From a philosophical point of view, the bricklaying robot is still a version of Talos, the bricklaying robot being an allusion to Ignacio Color, which we saw earlier, even if now cleverly civilianized. Is this really the end of the story? One that now celebrates the Bluetooth world of humans and hydraulic machines that do our quote-unquote labor? To avoid the compulsion to perfect Talos, what if we imagine other philosophical projects as a new beginning to the conversation? A robot called Derrida arrives at construction sites and digs around the foundations so that they are not always covered up, maybe endangering the building. A robot called Nietzsche removes bits and pieces of the building to produce unwelcome gaps and erasures. A robot called Heidegger moves bricks carefully and mind-numbingly slowly, taking a photo of each brick and sending the image electronically to a live feed exhibited on the screen at the Museum of Modern Art in New York, where aficionados are gathered watching and celebrating each brick. A robot called Zen arrives at the construction site and sits under a nearby tree for a year, documenting the coming and goings of butterflies, insects, and foxes before allowing anyone to start. A robot called John Locke travels around the perimeter of the property and measures it again. A robot called Marx that needs a lot of oil only builds for nonprofits while blurring out communist slogans. All of this is, of course, quite silly, but it is no sillier than having to repeat Talos for the millionth time. And that goes on and on and on. The ellipsis is cutting out another full paragraph there. And so this is a photo montage Mark made to accompany his essay. For him, this is what a robot named Heidegger could look like. And it's important to note that it does not have a body. It barely has a face. And so we generally hope that the book encourages young architects, like some of you here, to rethink what digital or robotic fabrication in architecture can be. We urge you to go out and name your robots. Thank you.
You guys want to take a couple questions?
If there's questions, we can take.
Any questions?
First of all, thank you very much for your presentation. At one point you alluded to kind of the role of drawings as things move towards more digital motive fabrication, and maybe that drawings might lose some of their, I don't know, their current role or their current necessity in the architecture to construction process. So I'm curious, like, would you envision that the role of the architect is sort of changing? Are we moving towards, again, a more active role in construction than we have in the last few centuries?
I mean, that, yeah, I mean, that's certainly James and Nathan's point in their chapter, because that really focuses on construction, like the state of construction right now. And, you know, they're building off of an ongoing dialogue, which is really unpacking the tension between contractors and architects. I mean, this tension has been around since forever, but right now, because of the advent of BIM, like building information modeling, like the models that we have are filled with information, and a lot of that information is actually more useful for contractors than the projected drawing sometimes. And so there are advocates for that. I mean, I witnessed a presentation by the firm, I think it's LMN from Seattle. They're building the Seattle Aquarium, and they built this like really complex tank for that aquarium in Seattle. And they presented the drawing set that they used, and it was like, I think it was like 8 pages or something for the tank, because everything relied on the Revit model. And they were really tightly coordinated with the contractors, and a lot of the contractors actually were not traditional building contractors. They were like dock builders, so they could build like complex geometries with less rebar than traditional contractors. And so they're basically, I think the trades, the construction trades are going through a transformation in that there's a lot more collaboration happening. And I think we just have to be aware of that. And I'm not really building right now, but I think the people that we included in the book, they're interested in the future of construction, and they put forth a lot of really interesting provocations, and that's just one of them, right? And I would argue that that is as much a social issue in the field as it is a technical issue, which is why that discussion of construction is in the social section, even though it has a lot of technical and material aspects to it as well.
No, I think that's right. I think for both of us, part of our desire to engage in this project is because we're skeptical about what digital fabrication can do for architects, or what it should do for architects. One possibility, like you mentioned, discussed in the book, is that it can bring architects or help architects re-engage with material processes and construction processes in a way that they maybe used to be, and the way that we become increasingly distant, to be arguably increasingly distant from those processes for one reason or another. I don't know is the answer. I mean, as a practicing architect, I think I'd have a really hard time convincing any of my contractors to buy into these technologies for one reason or another. And so I agree that although it appears to be a problem of technology, it's actually, I would say, Galo says it's partially social. I think it's more social than technological. It's more a question of accessibility and education and discourse and culture and economy, even, convincing people that this is not going to put them out of work. It's stuff like that. So the technology's all there and ready for them. Getting the buy-in of the many stakeholders that are involved in construction processes is fully associated with the problem, I think.
I guess the getting to construction is one thing. Did you guys ever really explore like maintenance of these like constructions through digital fabrication at all? Does that come up at all?
I don't think directly. I don't think it comes up directly in any of the chapters, but there is. So I showed the Gary Experience Music Project, which is now what's it called now? It's like the Museum of Pop.
Yes.
Yeah. So that is an early Frank Gehry building. It's curvilinear, right? There's a lot of curved drywall and the curved metal on the exterior. And if you're interested in like the maintenance of like complex buildings like that, there's a fantastic documentary called Gary's Vertigo. That is, I don't know if anybody's seen it, but it follows the window cleaners and the drywall maintainers in Bilbao. So in the Gary Bilbao Museum, like it's kind of mundane tasks, but like it shows like the weirdly acrobatic things that they have to do to get onto that glass and into the facade to like clean it and maintain it. And there's a part where they actually show that they have to like scrape the drywall in one of the curved railings like every day and repaint it. It's like really wild. So there are issues of maintenance, and I think that's a really good question. I'm not sure if anybody directly addresses it.
Sorry, I just wanted to try to understand the question. Is it a question of the maintenance of digitally fabricated construction, or the maintenance of digital fabrication practice, like the maintenance of the machines themselves?
I mean, I guess that too.
Okay,
There's
so
two
more
sides
that.
to it for sure.
Yeah.
Um,
I think both are interesting questions, and interesting, often not discussed, but really actually, I mean, more critical. Anybody who's used a digital fabrication machine has experienced a digital fabrication glitch, So again, I also think that's an interesting conversation is how that plays into design and construction processes, and to what extent we try, how we work through those glitches, and to what extent we embrace them. This question.
But there is a conversation about another kind of maintenance in the book, which is in the last interview with oh my god, I'm spacing out. Molly Claypool, Banaz Farahi, and Madeline Gannon. In that conversation, we bring up the issue of open source knowledge and programming. And Madeline Gannon talks a lot about maintaining open source projects, which is really labor intensive. And the idea that you can come up with a design for a robot, you can come up with a software design, and you can put it out there. But there is an expectation that you maintain that, and you have to constantly update it and debug it. And so I think that's more related to the maintenance of machines and technical knowledge as well. That is pretty under discussed as well. Like if somebody expects you to give you a tool for free, then they also expect you to keep it up to date. And a lot of dead GitHub projects kind of litter the internet.